Hello, and welcome to the exam review for the final for the Intro to Chemistry online course. My name is Jason Smith, I am your TA, and I will be showing you how to solve each and every problem on the exam review that was given by the Broward Teaching Center. So, let's begin. The first question says, which state of matter has atomic spacing that is close together and has definite shape? So remember guys, there are three different phases. There is solid, liquid, and gas. Okay? So solid has definite shape and definite volume. So in other words, it cannot change its shape and it cannot change its volume. Now, liquid has definite, does not have definite shape, and it takes shape of container, and it has definite volume. So in other words, liquid is where if I take my liquid and I pour it into something, that liquid will take the shape of whatever it is poured into. However, the volume of the liquid always stays the same. It does not change, it cannot increase, and it cannot decrease. And finally, we have gas, and it takes shape of the container. And it also does not have definite volume. So that means that the volume of the gas changes depending on the situation. So that means that the volume of a gas is not constant. So with this in mind, the question says which one has definite shape and which one has definite volume. Well, the answer, of course, is solid. Now, if the question had asked you what has definite shape and no definite volume, then the answer is none of the above, because liquids and gas have either definite or indefinite volume. Well, either way, solid is your answer, and you have your answer. Hi guys, let's do question number 2. Now question number 2 has a mixture of different atoms and isotopes, and it wants us to know different things about them. So first of all, it says here boron 9 has atomic mass of what? Well, remember guys, this number here is the same as me saying B9, and 9 is the atomic mass. So therefore, I can just say that boron has the atomic mass of 9. Okay? That one was pretty easy. Secondly, let's do the next one. A neutral atom of iodine, iodine 131, has how many electrons? Well, we also know this is neutral. So remember guys, whenever you have a neutral atom, the number of protons equals the number of electrons. So for neutral atom, number of protons equals number of electrons. Okay? So that's the same here. So since iodine is 131 is neutral, we just need to find the number of protons that the iodine has. And that number of protons is going to equal the same number of electrons. And so if you look at your periodic table, you will find that iodine has atomic number of 51. And so that means that there's also 51
The Teaching
electrons.
Center. UF's Learning Resource Center.
Okay? Now, let's move on to the second part of this question. Hi guys, and welcome to part 2 of question 2. Also, I apologize, so for iodine it actually has an atomic number of 53, not 51. So remember guys that it's actually 53 electrons, not 51 electrons. Secondly, let's move on. So the second question says, an atom of 23 magnesium has how many neutrons? So we know that it's magnesium 23. So what does that mean? What that means is that the number of neutrons is going to equal the atomic mass minus the atomic number. And we know that the atomic mass is 23, and so now we can subtract the atomic number, and the atomic number in this case is going to be 12, so that gives us 11 neutrons. Okay? So, let's move on to the second to last one. Or just the last one? Second to last one. Okay. So, the second to last one states that an atom that has an atomic number of 20 and a mass of 42 is an isotope that has an atomic number of what? So it says here that some element X has an atomic mass of 42 and an atomic number of 20, and it wants us to know what is the what an isotope would have for the atomic number. Now remember, the atomic number is the number of protons. The number of protons cannot change with an element. So in short, this is going to be the same as 20 protons because the protons gives us the identity of the element. And so finally, with the last one, it says the mass number for the isotope of potassium that contains 22 neutrons is what? Well, remember guys, atomic mass is the number of neutrons plus Z, and that's just going to simply be number of neutrons, which is 19, plus then your atomic mass, which is 22. So your answer is going to equal 41. And those are all the answer options for your problem here, and you have your answer. Now let's do question number 3. Question number 3 says, what group of elements separate the metals from the nonmetals and contain properties of both? Well, the answer is the metalloids. Now the metalloids are interesting because they contain both properties of nonmetals and metals, but they're neither. So that means that metalloids are semiconductors. This also means that they have some very non-metallic-like properties. And some also have metallic properties such as luster. But remember guys, if you were to want to remember where the metalloids are on the periodic table, remember that look for that staircase. That staircase represents where the metalloids are. But either way, the answer is metalloids for this question, and you have your answer. Now let's do question 4 together, guys. Question 4 says, which of the following pairs gives the larger atom, according to the periodic trends? Well, what we need to remember, guys, is that atomic size is a periodic trend, and it increases to the left and down. So which one of these atoms are more to the left and down? Well, what we can see here is that phosphorus is more down, so it's bigger than nitrogen. Silicon is more to the left than germanium, so it's bigger. And finally, iodine is more down than chlorine, so it's bigger. And so that's how you remember this trend. And you have your answer. Now let's do question 5. Question 5 says, indicate whether the compounds below contain only ionic bonds, covalent bonds, or a combination of the two. So let's look at this. We have NaCl, we have CO2, and we have NH4Cl. Now, let's look at each one. NaCl is an ionic compound, so it contains ionic properties. Also, because this is a metal and a nonmetal, they only contain ionic properties, because we have a metal and a nonmetal. no polyatomics. Next, we have CO2, or carbon dioxide. CO2 is a molecular or covalent compound. That means that the molecule is formed by sharing electrons amongst each other. So that means that this is covalent. And finally, also, covalent compounds never share ionic. Covalent compound molecules never have ionic properties. But if we look here, we have NH4Cl. Now, NH4 is what? NH4 is a polyatomic ion. And polyatomic ions are covalently bonded atoms that give off a charge. So that means that NH4 has covalent bonding properties, but it's an ion. So therefore, it has both, because NH4Cl is an ionic compound, but the polyatomic is covalently bonded. So these are your answers for question 5, and that's all she wrote. Now let's do number 6. Sodium hydroxide is used in drain cleaner and oven cleaner. How many grams of sodium hydroxide are there in 0.15 moles of the substance? Now, this is a little confusing, but here by substance they mean just pure sodium hydroxide. So simply what you're going to do, guys, is you're going to do just a simple stoichiometric relation. 0.50 mole of NaOH. And then for every 1 mole of NaOH, there is approximately 40 grams of NaOH. So you do the math, and you should get, give me a second. You should get around 6 grams as your answer. And you're done. Now let's do question 7. Question 7 says, calculate the percentage by mass of nitrogen in lead 2 nitrate. So what is percent by mass? Percent mass equals the mass of element per mass of compound. So example of this would be saying, how many grams of oxygen are in H2O? Well, what you would do is you would find out how many grams of oxygen there are in 1 mole of water, and then divide it by the molar mass of the water. So this would equal grams of element by molar mass of compound. And that's exactly what we're going to do here. So the first thing we're going to do is we are going to find out how many moles of nitrate there are in lead 2 nitrate. So we have 1 mole of lead nitrate, and then we can say for every 1 mole of lead nitrate, there are 2 moles of nitrogen, times then for every 1 mole of nitrogen, there's 14.01 grams of nitrogen. Okay? And so with that in mind, we can now use that, and we find out we have 28.02 grams of nitrogen. And then we are going to divide this by the molar mass. So the molar mass of lead 2 nitrate is 331.2. So the percent mass is going to equal 28.02 divided by 331.2 times 100, and this equals around 8.46%. And so that's the percent by mass for nitrogen in lead 2 nitrate, and you have your answer. Now let's do question 8. Question 8 says, what would be the expected product of the combination reaction between solid lithium and bromine gas? So remember guys, a combination reaction is just where you have two elements combining to form something. So what you got here is you have lithium solid plus Br2 forming lithium bromide. And so now we just need to balance it. And the question says, what would be the expected product? The expected product is LiBr, because you're just combining the two elements together to make a compound. And you have your answer. Now let's do question 9. Pentacarbon... I'm not even going to say that. FeCO5 reacts with phosphorus trifluoride and hydrogen, releasing carbon monoxide. And they give us the reaction. And they say the reaction will produce how many moles of carbon monoxide if we were given 5 moles of FeCO5, 8 moles of PF3, and 6 moles of H2. So first of all, we have this reaction. Okay? And first of all, we need to balance this. So if we were to balance this, it would look something like this. And you can do that on your own. But now what you're going to do is that you have 3 different starting amounts. So what kind of problem is this? Well, it's a limiting reactant. So what we're just simply going to do is we're going to start out with each of our mole values. 5 moles of Fe, 8 mole of PF3, and 6 mole of H2. And we're just going to do the mole-to-mole ratio for each one. And you're going to do this for each one. And you will find out that the answer is going to be 12 mole of CO, because that is the smallest amount. Because remember guys, in order to make CO, you need to have all the reactants present. So if one of them runs out, you won't have enough to make anything else. So the answer is 12 moles of CO, and you have your answer. Now let's do question 10. We want to draw the best Lewis structure for CH2Cl2. So we have CH2Cl2, and the first step is to count up your valence electrons. So what we have here is we have 4 valence electrons from carbon, plus 2 electrons from the 2 hydrogens, plus 14 from the chlorines. And so what you're going to get is you're going to get 20 valence electrons. Second step, you find your least electronegative atom, and you make it your center. Now, carbon is your least electronegative here. You never make hydrogen your central atom. So you put carbon here, and then finally what you do is you just place all the atoms around your central atom. And then you fill up the octets for everything. Now remember, hydrogen does not have an octet of 8. It can only have 1 electron. Or I'm sorry, 2 electrons. So let's see if everything's satisfied now. Well, carbon has 8 electrons, so it's happy. Chlorine does as well. And chlorine does as well here. So if we look it up, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And we have our full number of electrons, and we know that this is then the most stable. And you have your answer. Now let's do question 11. Question 11 says, a nugget of gold with a mass of 521 grams is added to 50 milliliters of water. The water level rises to a volume of 77 milliliters. What is the density of the gold? So remember, guys, density equals mass over change in volume. And this is going to equal 521 grams divided by 77 minus 50 milliliters, because that is the change in the volume. And then you just divide that, and you will get around 19.3 grams per milliliter as your answer, and you're done. Okay, second to last question, guys. Let's do this. So, in this question, it says here, the balanced net ionic equation for the reaction, if any, that occurs when the aqueous solution of silver nitrate and sodium chloride are mixed is what? So first of all, we need to write out the balanced molecular equation, which is just everything written out. Now we need to remember, guys, our solubility rules. Now with our solubility rules state, and also just on the safe side, I'm actually going to write that a little bit lower for you all. So, we have to remember if we form something that's a precipitate, aka insoluble, or if everything's soluble. If everything is soluble on the product side, there is no reaction. Now, silver chloride, however, is soluble. It's not soluble, so we have a solid. Remember, silver chloride is insoluble, so we have a solid. Because we are forming either a solid, liquid, or gas as a product, this will have a net ionic equation. So what we now need to do is we now need to split up our ions. Okay? And now we cross out the spectators. And now we just write out our net ion equation, which is Ag plus Aq plus Cl minus Aq produces AgCl, solid, and you have your answer. Okay, last question, guys. This one says, for the following reaction, identify whether the compound in bold is behaving as an acid or a base. And they underline H3O+. Well, remember, guys, acids are like good husbands or wives. They just give. So they're always going to donate their hydrogens. Bases are bad husbands and wives. They just take. So they're always going to be taking hydrogens. So here, H3PO4, which is phosphoric acid, is going to give its hydrogen to water. Therefore, we're going to have H3O+ as a product. Now always remember, guys, the acid becomes the conjugate base. And the base becomes the conjugate acid. So I'll say that again. The acid in an acid-base reaction always becomes the conjugate base. And the base always becomes the conjugate acid. So because H2O gained a proton, it now becomes the conjugate acid, which is H3O+. And so that means if we reacted this with, say, H2PO4-, we would get H3PO4 plus H2O as our product. And see here how the hydronium gave its hydrogen over to the H2PO4-. So therefore, hydronium acts as an acid. Well, I hope this exam review helped. I hope you do well on the test, and good luck.